My dad works in B2B marketing. He came by my school for career day and said he was a big ROAS man. Then he told everyone how much he loved calculating his return on ad spend. My friends still laugh at me to this day.
Not everyone gets B2B, but with LinkedIn, you'll be able to reach people who do. Get a $100 credit on your next ad campaign. Go to linkedin.com/results to claim your credit. That's linkedin.com/results. Terms and conditions apply. LinkedIn, the place to be, to be.
George Clooney and Brad Pitt's new movie Wolves is on Apple TV Plus September 27th.
That's where I want you to be now.
So if you want to see George Clooney and Brad Pitt, go to Apple TV Plus.
You got to start the story there.
Or if you want to see Brad Pitt and George Clooney, go to Apple TV Plus.
I am enjoying the show.
And if you want to see their new movie Wolves,
You can't do it, I'm going to help you out. I can do it, so do it.
definitely go to Apple TV Plus.
Admit it, it's cool. Okay, fine, it was very cool.
Wolves, streaming September 27th on Apple TV Plus. Rated R.
This episode is brought to you by Jira. Ever wonder how those big marketing campaigns that make headlines get delivered on time? It all starts with Jira, the only project management tool you need to plan and track work across any team. Every step of that campaign is organised in one place, from launching the campaign all the way back to designing ads and writing creative briefs. Get started on your next big marketing campaign idea today in Jira.
The Athletic.
We explain what Adrian Newey will bring to Aston Martin and explain the value of a brand new wind tunnel to F1 teams given the facilities at Silverstone are one of the reasons he cited for signing up. And we answer your questions about windscreens, sensors, Jordan 199 fuel injectors and tyre beads. Welcome to another episode of the Race F1 Tech Show, where we delve into all things tech and tech adjacent in Grand Prix racing. I'm Edd Straw, and with me as always is Gary Anderson. Enjoy the Singapore weekend?
Well, I enjoyed the Azerbaijan weekend, yes.
Oh, see, that tells you a lot, doesn't it? Yeah, I'm flying off to Singapore shortly, so
There you go.
I've already moved on. It's always about the next race in Formula One, isn't it?
It's always about the next race. Yeah, the next race is going to be interesting, actually, Singapore. It's a race that, it's a night race, and it was also pretty tricky for some teams last year. But going back to Azerbaijan, it was a really good race, I thought. It was a fairly active all the way down through the field. It's not a circuit where overtaking is easy by any means, as we saw, but I have to say that Oscar Piastri took a car that probably deserved to be on the podium or pretty close to being on the podium and won with it. And that shows the mark of a great driver. That's really where it comes down to be honest. The day you can win with a car that's not quite capable of winning. So as far as all the concerns of looking after tyres and strategies and team orders and everything like that, he just he saw past all that and really went for the win. And in my book, that overtaking manoeuvre on Leclerc was a total commitment, but an uncontrolled commitment, I suppose you might call it. So he knew he needed to get in front to save tyres from the turbulence. He knew if he could get Leclerc behind him, that would give the problem over to them, which obviously worked out right. It seems like the McLaren uses the front tyre just a little bit more than the rear tyre as far as the tyre degradation or the tyre consumption is concerned, whereas the Ferrari was the other way around. And one of the things you never want on a circuit which has got lots of slow corners is rear tyre degradation, because traction just becomes a nightmare. So pat in the back to Oscar Piastri for seeing through all the stuff that's been going on since Monza. And he's a guy to see in the top step of the championship podium, and in not very many years either, I think.
Yeah, great example, Monza and Azerbaijan, of how different tyre characteristics can go against you or for you, because that front left struggle they had at Monza held McLaren back, whereas the fact they worked the fronts a little bit harder and the rears were better helped them in Baku. So that's just shows how track characteristics can swing the battle. So let's, as usual, have a free choice of topic for the start of it. So what's on your mind technically at the moment, Gary?
Well, I think the big thing really, I suppose, is Adrian Newey moving to Aston Martin. It's the rumour's been around for a long time, and I'm pretty sure we all knew it was probably going to happen, but it's now been announced. Obviously, he can't start there until more or less the middle of next year. But what it does do is let him get his head sorted out relative to the new regulations. He's not involved in the current regulations. He won't really be involved in next year's Aston Martin. So it'll be 2026 that he'll be, fully and 100% focused on. It's a different job that he's taken on, I suppose. He's obviously come in as a shareholder of the company, getting paid a huge amount of money, all that sort of stuff. But he's coming in as a sort of overseer of all the top end structure that they have in Aston Martin, which is the job he really wanted, I suppose. Whenever you look at it, that's the job he was sort of pushing for at Ferrari, to make sure that the 20 or whatever people that would be directly below him, that he's got control over who they are, and then it's up to them further down. So I've always believed in that, fir tree management structure where you got a guy at the top and then it gets bigger and bigger as you go down, as opposed to the flat line management, because I've never really seen the flat line management work. There's always a bit of finger pointing across that line. It's your fault, it's his fault, it's the other guy's fault. You need somebody at the top that's actually going to be the guy that really does sort of lay it in the line. He won't always get it right, but then it can oversee the whole thing. So I think the structure that they could create at Aston Martin could be very, very strong. What they've got to do is get acceptance from the next level down of people, because they're a little bit top heavy in that area. So I would imagine there might be some people moving around a little bit in the ranks before it all functions correctly. But I think it's a good sign for Aston Martin.
It's interesting the point you make about everybody will have to kind of get on board with Newey coming in, and there's a little bit of sorting out to do with the structure, and they've said that Newey himself will be charged with sorting out that structure, and he'll do that, I imagine, working with Andy Cowell and Bob Bell in particular. That triumvirate seems very important. But what's it like when you're, say, a technical director? You've been a technical director. Dan Fallows is the technical director. Now, he knows they've brought Enrico Cardile in. Cardile doesn't start till next year, and then Newey's obviously coming in this sort of uber tech role, and also having a say in the sort of wider direction of the team. So how do you think he reacts to that? Because obviously he sort of had his chance at being the main technical lead, and then there's now two layers in above him, or at least there will be by the time we get to March next year when Newey starts as well.
Yeah, I mean, it's always difficult, because I think that what we see is that whenever somebody tries to create a position like this, they create a new handle for the jug, and it's where those handles end up at. I'm sure there has been consultation, or I would hope there would have been consultation with the Dan Fallows and all of those technical people that's coming in. There's room to think that, there is room for them all. You might have to sort of separate out, track performance and chassis mechanical, chassis aerodynamic, X, Y, Z. And because of the size of the teams these days, that's not the wrong thing to do. And what I'm really saying is that somebody, if you do have that, somebody needs to look at it from above, and that would be Adrian's job. So I'm sure there'll be a few heavy discussions before it's all evolves correctly. For the best solution to the team need to come first. That's the important thing, to be honest. And I think having Adrian coming in as a shareholder in the team, he's there, he is part of the team. That's his first sort of venture into that area. I'm very surprised he didn't have a fairly decent stake in Red Bull, because, Red Bull, it was one of those sort of things where, to be honest, that's what he should have had. He deserved that at Red Bull, to be honest, because he's built them up from the Jaguar days to what they are, to what they were and what they are now. And he deserved a stake in that. So I'm very surprised that didn't happen. But obviously, I don't think it did. If it did, he hasn't got them anymore. So, it's all about setting up correctly and making sure the other people don't get their ego trodden on, because, at the end of the day, if somebody's disgruntled, he can drag the team down easier than if he's really, motivated. It's very, very difficult to drag a team up. The team needs to be completely motivated in itself. It's not just one person that makes the team successful. Adrian won't be able to do it on his own. He needs people around him, as he's had at Red Bull, as he had at Williams, as he had at McLaren. So you need a group of people to be motivated. And as I say, one person can actually drag the team down a bit. And I've been involved, obviously being a technical director, but it was a much smaller sort of organisation at that time. So a completely different time. But still just as important, you had to make sure that the guys that were doing the various parts of the company were motivated within that. And you had to look at it from slightly above. You had to know a bit about everything, but not be a specialist in anything. And that's really the important thing, I think, is being able to put in your tuppence worth whenever you're having a meeting, a conversation about something, just to question something more than anything else, but allowing the experts to get on with what they do. And just making sure that they're all pulling in the same direction. As I always said to our guys, before you sort of start detailed design, make sure you know whether it's going to be a washing machine or a dishwasher, because they both look very similar, but they can be very, very different how they operate. So make sure you know what you're going to design before you start, and make sure everybody else is aware of what you're going to design, because that way you're all pulling together.
Were you surprised to hear that he's committed to being 24/7, a full-time technical lead for at least the first few years? He's 66 in December, so he's still obviously he's still fully functional and everything, but that's a big old commitment to be making when you're at a time where some people are thinking about retiring. He's obviously up for the challenge, but I think we're expecting him to be a bit more of a super consultant rather than someone who's there basically 24 hours a day thinking about Aston Martin F1.
Well, I think, yes, I agree with you. We all expected him to be an outside consultant and, in my opinion, fade into the Aston Martin supercar side of things as the few years go past. But, I think Formula One's got to a point now where it's big enough where you can just... 24/7 means that the time you want to put into it, you put into it. If you need to sort of get up one morning and say, I'm sorry I can't quite make it today, I feel a bit knackered, then you don't. So 24/7 nowadays with a team the size they are is a bit different from 24/7 back in the old days. Whenever if you didn't do what you needed to do today, it didn't get done. It will get done. And obviously communication, liaison from other parts of the world is very, very possible. I think what it's really saying is he will be there to observe 24/7. He'll be available 24/7 if he does need to be there. And communication has to be strong. I sort of don't expect him to be back on a drawing board with a pencil very much. I'm sure he will still want that facility. Because a creative mind does. It's one of these things where whenever you're doing a job that you love doing, you want to do it. And I think Adrian loves to sort of understand stuff by doing some drawing himself. So I think, when he gets up in the morning, I think motor racing it's not his life by any means, but it's what his mind's full of. And that means that you do commit 24/7 to it. Even if you're not there, you're still, in the background, you're thinking about it. And as I say, with today's communication availability through internet and whatever, it could be sitting anywhere in the world and be there. Like, obviously, doing podcasts like this, you've got communication. You can communicate from that far and distant lands.
Well, it's certainly going to be a fascinating story to track, how he gets on when he's there. And, of course, following in the footsteps of yourself, Gary, as you were the founding technical director of that team many years ago. So finally, he's getting to the Gary Anderson level. Finally, he's getting there. Now, I mean, I appreciate the guy dramatically for what he's done for Formula One and what he is as a person. I don't know him sort of exceptionally well. I have sat and chatted with him a few times, and I've had a few beers with him here and there. And he's been one of these honest people who's always said it as it is. And I appreciate that, because that's what you want. There's too many, and I'll use the word bullshitters out there, but he's not one of them by any means. He's just a straightforward bloke who, knows the difference between right and wrong. Yeah, absolutely. And that's one of his great strengths. Our main topic for today is wind tunnels in F1, and it's appropriate because Newey said that how impressed he was with the factory, and the wind tunnel played a part in convincing him to go to Aston Martin. Now everyone's very familiar with wind tunnels. They've been a key development, or the key development tool, in fact, in F1 for decades, but they're still shrouded in mystery to those on the outside, and not all wind tunnels obviously are created equal. So given how important they are, I guess an important question as a foundation of this conversation is, why are wind tunnels so vital? Why are they the number one design and development's all still in F1 in 2024?
Well, it's one of these sort of situations where, you have to optimize the car away from the track, because track testing, sort of straight line aero testing, all of this stuff is now gone. You can't do it anymore. So there's more and more reliance on a wind tunnel and understanding it. But the wind tunnel, it's only a tool. If you don't question the results at the end of your wind tunnel session, then you will get yourself in trouble. It's a tool to prove things and to make sure that you're not going down the wrong path too easily. You can't, there's certain tools that you need in life. And I suppose if you were to say, is CFD or wind tunnel more important, either would be important. If one was banned, the other one, obviously the other one would just become the more important one. CFD gives you a very good understanding of airflow off the surface, I suppose you might call it. Whereas the wind tunnel gives you a better feeling of loads and with different characteristics. Now, wind tunnel running and wind tunnel limitation, obviously it changes as things go by. McLaren, with their performance lately, will suffer next year at some point in time for wind tunnel time, because they're doing a better job now than they were. Red Bull, for example, if they don't win the championship, will get a bit more time. So it's I'm not sure that the percentage change is quite sufficient to really influence the outcome. But still, never mind the wind tunnel time. As I say, it's the people that you have around you that question the results that makes the difference between a car being good and a car not being good. Many times in my life, we found something that gives lots of downforce, put it on the car, and instead of the driver making one mistake in 10 laps and running a little bit wide or something, he makes one mistake every 2 laps just because the car's become too sensitive. And you don't want that, because the driver needs to have this plateau where he can realise what his car is and how far he can push it. And that's the important thing. Now, wind tunnels are limited still to certain characteristics. You go through a ride height map, which you create, and you can plot that ride height map to the car characteristics, starting off from a slow speed corner at high ride height, getting lower and lower and lower, hitting the brake pedal end of the straight, seeing where the centre of pressure shift is with all that stuff going on. You can also do roll, yaw, steering angle, and it's building a model that does all that automatically for your wind tunnel run. So you get a full set of characteristics of a car going through a fast corner with 3 degrees of wheel lock on it, or road wheel lock, up to a slow speed corner with like 12 degrees of road wheel lock. But all those characteristics of the car going through that range of corners, and the ride heights at that range of corners, and the yaw and the roll at that range of corners, it's a massive set of numbers, huge amount of data to go through and decipher as to whether or not a certain component you put on the model is working correctly or not correctly. And the one thing we see the cars doing a lot is sparking going down the straights, for example. You can't do that in the wind tunnel because you just destroy the model or the belt. So it's a tool to gather a lot of data, but you have to analyse it correctly to try and pick out the good and the bad and the ugly. And as we've seen in many occasions, some teams have gone for the ugly, it hasn't worked for them. Some teams have gone for the bad and it's been just about the same as they had before. And some teams have gone for the good and it's moved them forward. And it's the people that will pick that part out of there, not the wind tunnel itself. But you do need that data. It's like any data. They gather bucket loads of data from the car running around the track. And you would need years to analyse it all in deep detail. So, the tools that you have behind the scene and the people that you have behind the scene that will make the decisions on whether it's good or bad.
And looking at the wind tunnels physically, obviously I think everyone's very familiar with the concept of you've got a car model and you're blowing air at it, which is the most simple version. But of course it's far more complicated than that. A wind tunnel, it's a closed loop in terms of the airflow, and that whole physical challenge actually of creating that airflow is an aerodynamic challenge in itself, isn't it? Because it's not just blowing air around a big loop. you've got to do things aerodynamically within that loop in order to make sure you've got the airflow you want, the consistent, reliable airflow. You've got to have temperature control. You're accelerating it in certain places. So that in itself is just hugely complicated, creating that and making sure it's working consistently. So how challenging is that, and how big a gain can you get from having one that does that really, really well, which is what Aston Martin, of course, is aiming to do with their kind of ground-up new build wind tunnel?
Well, that's where technology has taken the wind tunnels. As you said, we used to have an open wind tunnel as such, just a working section set in the middle of nowhere, and a fan moving the air around, and it still did a job. That's many, many years ago. And then you got to the closed loop tunnel. And as you say, the tunnel itself, the tube, I suppose you might call it, has quite a big section. And there's a fan in it, and there is a cooling facility in it, because obviously you put energy in there to move that air around. Then you put heat into it. And the one thing about heat and aerodynamics is that it changes the aerodynamics. So in the wind tunnel, for example, you strive to keep the temperature stable so you can back-to-back components. Unfortunately, on race day or a race weekend at a racetrack, it's not like that. So that's one thing where the wind tunnel is limited a little bit. The temperature of, for example, the belt, you'll try and control again at the difference between the ambient and the road. So you know that the temperature of the air or the surface underneath the model is relative to the ambient, but again, that changes dramatically from one practice session to another. The working section of the tunnel is where you bring the airspeed up. It's smaller than the main tunnel, the main tube. And again, the belt is rotating, the air is moving, whereas again on the track, the car's moving on the road rather than the belt moving underneath the car, and the air is still and the car's moving through it. So again, it's a different sort of set of characteristics. Now all of that can be tidied up, or the offset's limited, but they're still there, and that's why I'm saying about reading the data. In the past as well, if the working section wasn't big enough, and whenever we had the cars with lots of outwash, that would affect the flow outside of the car, outside around the wheels. And if the working section wasn't big enough, the walls could affect the downforce. I remember using a wind tunnel where you get more consistent results just because you left the door open, because it meant that the weight coming off the front wheel wasn't affected by that part of the wall because the door was open. So, again, compromises all the way. And then some people invented a variable wall, so you could actually change the wall of the wind tunnel. You had pressure sensors all the way down the wind tunnel, in the roof and in the walls. And basically, you try to mimic the pressure on the wall that you had with the last few bits you put on the car. So if you put something on the car that, let's say, had more outwash, it would affect the pressure on the wall, and that wall would change its profile to get the pressure back to the same as what it was. So you get more realistic numbers as to what it did to the actual car model, rather than the walls of the wind tunnel affecting it. So, if you take Indy cars, for example, raced around ovals, or NASCAR, the difference between the car running close to the wall and running in the middle of the track is horrendous. And that's an example of how the wind tunnel, if the working section isn't correct for your set of regulations for that set of regulations for the car, it can have a big influence on the performance of the car. And that, again, as I say, is where you need the people with you to understand and read between the lines a little bit, not just believe the results of a wind tunnel test that A was better than B or B was better than A. You really have to look at it now. Why did that happen? So yes, it's a fantastic tool. Technology has moved on a long way. One of the biggest things has been able to measure the actual load underneath the tyre, as opposed to just the model hanging from a beam and a set of scales above it as such, measuring drag and downforce. Being able to measure the load on the tyre through the belt has been a big, big asset. And all those turning vanes and that you see on the brake ducts, especially the rear brake ducts now, because the front is sort of limited a little bit with the regulations. But all of those have come since being able to understand the devices that put load into the tyre. Because if you could do it, and Colin Chapman tried many years ago and failed, if you could create all the load into the tyres directly and not go through the sprung part of the chassis, you would have a much more consistent car because it wouldn't be moving around whenever you hit the brakes and roll and yaw, etc. It would be putting the load directly into the tyre contact patch. And all of those bits and pieces on the brake ducts that we probably don't pay enough attention to as far as the media is concerned, as coverage of good car, bad car, those bits are critically important because the load that they create might be small, but it's on the tyre all the time. And that's the important thing. It's not caught up in the suspension lag of the car moving. So very important. It doesn't have to be sprung. So yeah, technology and wind tunnels have moved on a long, long way. But you still need, at the end of the day, people that can read between the lines of the results and make decisions as to what's good and what's bad.
Well, the bottom line is the wind tunnel it's a simulation. And like all simulations, there's limitations to it, and it's all about mitigating those limitations. But as you say, I think the adaptive wall technology has become very popular. Now, of course, the wind tunnels are 60% scale. 50 metres per second is the maximum airflow speed. And of course, you have to remember that there's an effect there, isn't there, in terms of scale speeds, in that's not 50 metres per second in the real world, is it? It's actually slower than that for the scale. So that there's all those sorts of factors to consider. You mentioned tyres there. Pirelli makes bespoke wind tunnel tyres that are 60%. They used to make 60 and 50%, but everyone's now on 60% tunnels. And that's not just scaling down the tyres because you have to do things to get the same deformation characteristics. So that's hugely sensitive. I wanted to ask you about belts, though, because obviously, again, the basic idea of the belt, very, very simple, like a little conveyor belt, isn't it? That's what the earliest iterations of the rolling road elements are. But these have become more and more high tech over time, haven't they, in terms of wanting to get the best possible data, keeping them consistent and smooth, so they're not sort of lifting towards the car because of the low pressure. And then if you counteract that creates all sorts of other problems. But with what we've got now with these ground effect cars, there's all sorts of talk about things that teams are doing with the belt technology as well, in terms of simulating different types of track surface even. It's incredibly complicated what's going on there. And you can see why that must be a hugely beneficial thing to be able to do if you can actually understand these tiny sensitivities where even the track surface can have an impact on the way your aero works.
Yeah, I mean, the belt, back in my day, it used to be a big, as you say, a conveyor belt, like a rubber belt. And you lived with what you got. Sometimes even the joint where the belt was, you'd get this bump all the time as it rotated. But that's a long time ago. Now, most of them are be a metal belt or a Kevlar belt, and they have different surface treatments on them. You can get whatever, like buying some sandpaper at the local DIY shop, you can get whatever level of treatment you want on it. And that's where the circuit measurement that Pirelli do and all the teams go and do now, measuring the surface, taking photographs of the surface and analysing it. You would try to mimic Mr. Average track surface, I suppose you might call it. And that's why some track surfaces, we hear a lot about it, this is a very aggressive surface or whatever. That can be because of how the tyres work on it, but it's also how the aerodynamics work on it, because it will change the characteristics. Because as I say, the one thing about it is the car's travelling across the surface as opposed to the surface travelling across the car. And the air at a race circuit, unless it's windy, is sitting still and the car's travelling through that. So we talk about separation, airflow separation. You can actually pull the airflow off the track surface as well. If your underfloor is working too hard, it is a venturi, and basically the other side of the venturi is the track surface. So although you're trying to pull that air from the front of the car to the back of the car and speed it up to give you downforce, on the way there you got a lower pressure, so it can separate from the ground. It's one of those sort of things that's it's pretty difficult to do anything like that, but it can happen. So belt technology has moved on a long way. They're in the sort of rolling road, as we call it, there will be a vacuum underneath the belt, holding the belt down, and that vacuum will be varied relative to the downforce the car is producing. So it won't be just linear. So in other words, you won't have a huge vacuum on it whenever you start the model, whenever you start running the model. But as the downforce changes, you want to keep the belt away from the bottom of the car, because again, back in the old days, you could lift the belt off the bottom of the car, so your theoretical ride height of 20 millimeters was actually 15. So it changed everything in the car. So the belts are much more stable now. They're run on a sort of set of bearings, loads and loads of small bearings on the surface. So they're pulled down onto these bearings with a vacuum. And they're, as I say, the stability of that belt, the surface treatment of that belt can change the characteristics of the aerodynamic package that you're creating above that belt. So, whenever we see things like a manhole cover getting lifted up by a car going across it, that's the same thing as the belt is trying to, or the model's trying to lift the belt off the rolling road. So it's all just needs to be run enough, tested enough, experimented with enough to know that you're in a good window. And then, as you say, you've got a simulator for that. It's a simulator that I would classify as 75% correct, I suppose. It's never 100% by any means. But technology's moved on a bit now, so as I say, they are pretty good tools nowadays, pretty exciting tools to run and work with. But it's still a simulator.
Yeah, and of course, everybody as a result talks about correlation, and that's often talked about as if it's an absolute single thing. But of course, it's not, is it? Because the wind tunnel gives you numbers, and as long as those numbers are accurate and consistent, then it's how you take those numbers and crunch them. And that's been one of the things under these regulations that all the teams have talked about this. They've had to change a little bit what they're looking for in the numbers. Even Andrea Stella at McLaren talked about it a few years ago when we spoke to him. He said that actually with the old way, that regime, they were analysing the numbers, some of the improvements they made would have actually been a no, this isn't an improvement, because they were looking at kind of things that were fettled and developed for the old rules era, but now it's different things you're looking for. So that's the thing, isn't it? The data doesn't give you answers. The data gives you the raw material from which to divine the answers, and that's the key step in correlation, isn't it? Yes,
it is a key step. The thing about it is, it's important to learn from what you've done wrong, as well as learning from what you've done right. There's always a reason for it. If you just say, we developed that front wing or whatever it be, that underfloor splitter or whatever, and it doesn't correlate. We don't get the improvement that we thought we'd get on the racetrack, and you put it in the bin, that's a waste. Whereas if you look at the data, analyse it and see what the changes were, and then try and make sure you stay away from that direction of change. You can learn something from it. Obviously, if it's the other way around, it's easier. If the car goes faster, it says it should go faster, then you exploit that a bit further. But, as I say, the tendency for these cars, ground effect cars, is to run as low as possible to the ground so that they seal to the ground along the floor edges. That's why whenever we had ground effect in the past, you had sliding skirts. You couldn't run in a wind tunnel back then, which we didn't do very much of at all at that point in time. You couldn't run with a sliding skirt on the wind tunnel belt. So at the end of the day, you had a major compromise. You had to have the belt, moving up, pinned up to the side panel with a little bit of a gap to the floor. That's the same as now. You have to have a gap to the floor. Or to the belt, from the underfloor. So you end up with as I say, it's a compromise before you even start, but it's understanding those compromises and knowing when to react to those compromises. That's the important thing.
Well, there's obviously so much to the art of wind tunnels and technology, and teams keep them a very closely guarded secret, but that's given a bit of an overview of the wind tunnel war that's going on. As we said, Aston Martin's got their brand new wind tunnel that they're starting to move towards doing the initial calibration and everything. Obviously, you put in proven geometries and you have to go through that process of making sure everything's working as you hope before you move it into frontline development. But that's going to be a key tool for them for the 26 car. Red Bull have got a new wind tunnel in the pipeline. Obviously, McLaren recently had a new wind tunnel, though it's still within the same physical wind tunnel they had at MTC. That was the old wind tunnel they basically abandoned because it was a little bit too constrained. They had problems once the kind of off-body aero and the outwash became so important, created all sorts of problems there to go and work in Toyota for years, but they've corrected that now. So there's a huge amount going on with wind tunnels, and it's very clear that Adrian Newey's looking forward to playing with the one that Aston Martin have got. Well, as always, we'll finish off with some listener questions, always a favourite part of the podcast. If you've got a question you'd like to ask Gary about any matter, technical in Formula One, current, historic, as long as it's tangentially related to technology, we are the place to ask. If you'd like to send in a question, send it to podcasts@therace.com. That's podcasts@the-race.com. You can either send it in as a written email, or if you like, you can do the little chosen path of recording a voice note and sending it through. And if you do that, let us know your name in the voice note as well. The first question comes from Bill Cannonberg. F1 cars have a jagged piece of clear material immediately in front of the driver's head. Do the teams call it a windshield? Why is it jagged? And what does that do to the airflow?
Well, Bill, some teams have a jagged piece. Some teams have a more uniform piece. It is called a windshield. It acts as a little bit of a trip because basically the cockpit in itself runs at a sort of low pressure inside of there because it's such a big hole. So the airflow that comes over that surface would, if you didn't have that screen, will turn downwards as such. And it causes a bit of grief for the driver's helmet because the shape of his helmet means that he's got lift on the helmet. So the air accelerating over the top of that surface is lifting up. So you've got airflow that comes down into the cockpit and then goes back up because it's pulled up by his helmet. So it's one of those sort of situations where you're trying to stop the turbulence on the driver's head. Now, if you think of the cockpit, over the last couple of races we've heard Mercedes drivers complaining about heat in the cockpit. And some of the reason for that, they talk about the skid underneath hitting the floor and all that. But if that's generating that much heat, it's pretty bad. Normally, what you see the mechanics doing when they bring the car into the garage is putting their hand underneath there and just feeling the skid to see the areas where it is hot. Because you can't always go in there with a vernier or a micrometer and measure the thickness of it. But if you can feel it and feel the heat in it, then you know where it's touching. But going back to the windscreen, going back to the cockpit, that low pressure in the cockpit pulls hot air in through any wiring holes, plumbing holes that's in the cockpit, because all the electronics in that or a lot of the electronics are housed inside the cockpit. So if you get any holes between the engine bay and the cockpit, air will travel into the cockpit as opposed to the other way around. The screen itself then acts as a little bit of a trip. As I say, some teams just have a uniform plastic screen which trips the airflow up. Others, Mercedes for example, have more of a jagged edge. It sort of does the same thing. In theory, they're trying to sort of set up little vortices coming off those points, those jagged points, which again in theory should stop some of that airflow from turning down into the cockpit because they got a bit more power. But I've never seen the difference in it in my time of testing it. If the driver needed a screen to stop it tripping on his helmet, then you put a token gesture there. It does a little bit to stop that airflow from turning down into the cockpit, but mainly developments around the helmet have helped the turbulence on the helmet more than anything else. The helmet developments itself, the little turning vanes you see on them and the little turning lip at the back and how they integrate with the headrest shape has been more important than most things. So, everything's a gesture towards trying to make the driver more comfortable. And with these ground effect cars, again, you get the head turbulence plus the fact the car's bouncing down the straights, and most cars still do it to a certain extent. If they're not bouncing, then they're banging into the ground and bouncing very sharply, and the Mercedes does that a lot. So you can see them putting a lot of attention to try and stabilise the head because it's for a huge amount of reasons. Again, as I say, the porpoising, the hitting the ground and the turbulence, add that all together on a bad day, and it's pretty difficult for the driver to see.
Next question comes from Troy Barros. Now, it's a question about a Jordan that's the year after you were there, but I'm hoping you'll have some knowledge to impart on this. Troy Barros says, I have a Jordan 199 and I'm currently bringing it back to life with a 3-litre Cosworth CK V10 instead of the unavailable Honda engine. My question is about fuel systems. The mechanical fuel pump and regulator originally supplied fuel to the injectors at 20 bar. As the regulators are now unavailable, I'm looking at running a 10 bar system with electric pumps and MotoGP injectors, but still mounted above the intake runners. Do you see any issues with the 2000s spec V10s running with 10 bar injectors instead of the original 20 bar units? Why was the original pressure that was used so high?
Well, it's one of the things about the pressure is the pressure now is huge on the injectors. Actually, they've had to put a limit on it. I forget exactly what it is, but it could be up to something like 100 bar now. But it basically gives you better atomization. Fuel and air the mist, the pressure coming out of the injector is more of a mist. The higher the pressure, the better it mixes with airflow, and the more uniform fuel-air mixture you get into the engine. So that's better for combustion. Because one of the things you had with the V10s especially was the stroke and bore diameter. And it was a compromise because of the RPM you're trying to achieve. Basically, the bore diameter was so big that if you didn't get the good atomization, good intake atomization, I suppose you might call it, that you would get few unused fuel around the outside diameter of the piston. It wouldn't actually burn fast enough because the revs were so high, the stroke was so short, it just couldn't burn in time. So the better atomization you got, the more of the fuel that went into the engine you could actually use, and then the more power you got. So it'll work it'll be fine with 10 bar. It'll all work, no problems whatsoever. You just wouldn't get the same power out of it, and the same fuel consumption, or the reduced fuel consumption that a 20 bar injector system would allow you to get. So no big dramas, I wouldn't say, and I'm really glad you're bringing a Jordan back to life. Whether it be one of my era or the one after my era, I don't really mind, but it's nice to see somebody bringing one of them back to life. There's not that many of them around. We had a small window in Formula One, but it was a good window, so it's a very important name to me.
The next question, in fact, is a two-part question, so we'll address those separately, comes from Thierry Leclerc. I'm from Quebec and a big Gilles and Jacques Villeneuve fan, and I'm currently doing my PhD in electrical engineering, optics and photonics at Boston University. First of all, thank you for the good work that you do on all your podcasts. I really enjoy them. I have two distinct questions. Firstly, is there any optics engineering in Formula One? For instance, is there any work on optimising the performance of highly sensitive but robust pressure sensors such as fibre optic based ones? I know that people in my field design high performance sensors for things as varied as nuclear reactors and airplanes. Or are sensor designs fully dictated by the FIA?
Well, Terry, first of all, I'm a big Gilles Villeneuve fan. I was around at his time, and he was just one of those incredible drivers. Not so much the Jacques Villeneuve fan, but the Gilles Villeneuve fan, yeah.
Well, you were chief mechanic for his F1 debut, Gilles Villeneuve.
Well, yeah, that's a long time ago. Silverstone with his McLaren, yeah. But, at the end of the day, he was a driver. He was just someone who drove the car. He drove it flat out from the minute he left the pit lane to come back in again. No matter what happened. I mean, at Silverstone on that day, he came into the pits with the engine running, saying that during the race weekend, they came into the pits with the engine running, and the oil pressure was at zero. And I think that day he learned a lesson: never give up, because we obviously said to him, look, the engine's still running, can't be at zero. The gauge has gone wrong, so he took off again, and that was a lesson, I think. Never give up. Just keep going till the thing all dies in front of you somehow. But going back to your question, The sensors aren't really defined by the FIA. You need to pass the technical spec of the sensors through the FIA, I believe, to just make sure that you're not trying to do something with it that's seen as contravening the regulations in any way. But as you say about the sensors that your colleagues have been designing, I don't know. All I'll say is that if they are light, small, trustworthy, and can give a Formula One team some information, then they will be used. And especially if they're used in aircraft, if they're a commercially available component. There is, many, many, many sensors across the car, from the pressures, temperatures, loads, you name it. It's there everywhere on the underfloor, the front wings, airboxes, engine intakes, exhaust systems. They all use sensors to get, again, these bucket loads of data that they've got. Some of those sensors they do things with, some of them they don't do things with, but it will be used. And as I say, you might need to just get if it's too trick, you might just need to get clarification from the FIA that it's okay to use it. But yeah, I'm sure they are used somewhere.
Yeah, there's a few sensors that are FIA mandated, such as the fuel flow sensors, that kind of thing. But for the most part, it's free, and they certainly invest a lot in making sure they've got the most optimized ones. They have their technical partners to push that. So yeah, it's that there's plenty of development that goes on there, but it's a good thing to ask about because it's a topic that's not talked about a great deal by teams. The second question from Thierry is, what are the major differences between the different power units on the grid? For instance, reliability aside, what makes the Mercedes power unit so much better than the Renault power unit?
I think at the end of the day, they've all honed in on each other to a certain extent. I think Ferrari are still a bit different in their turbo size and the speed they run the turbo at, but the other ones I would say have all honed in a little bit on what Mercedes have done through time. Again, it's like anything, whenever Alpine, as we call them now, or Renault have a good day, they're not bad. They're pretty decent. So I wouldn't say there's a big difference in any of the engines. Their actual end result of output. Some will have, better output at whenever they're trying to use the MGU-H to get more power because of the turbo speed, i.e. the Ferrari. They can maybe get a little bit more out of it at one end of the RPM band or the turbo RPM band. Others, will be using the turbo off the corner a bit better. So it's a combination of bits and pieces, but all of them, I'd say, are now pointing in the same direction as far as power is concerned, within, as I say, a small window of 20 horsepower. And that 20 horsepower, at the end of the day, is out of 950, I suppose you might call it, whenever you add all the power, the ICU power and the electrical power. So it's not a big percentage anymore. Some circuits it will prove detrimental, and some circuits it won't. But whenever F1 went to these hybrid regulations, Mercedes clearly led the way. So their understanding during that period was clearly very high, especially at the beginning. And that does mean that everybody will point themselves in that direction. But say the Ferrari has still stayed a little bit different with their turbo size relative to the turbo speed. So it's not a big deal, to be honest. I think Renault do lag behind, but it's a small amount.
Yeah, certainly the amount of power is not vast. Amusingly, when the workers at Alpine put out their statement recently, obviously they've had strike action. They're objecting to the fact that Alpine is planning to shut that down. They attributed 20% of the underperformance of the Alpine team to the engine and therefore 80% to the chassis side. So there you go. That's the engine side split. I'm sure if you asked around at Enstone, they'd have a different answer. The final question is from Mark Malipard, who says, this question is about tyre beads and how a tyre seats on a wheel. I've raced on a variety of surfaces, and on dirt we used bead locks which pinch the tyre to the wheel so it doesn't move in high grip moments. On pavement, we didn't want the added weight of a bead lock. I always monitored how much a tyre spun on the wheels. Is this a problem in Formula 1 with the incredibly high braking forces? Is there a simple solution such as surface texture or something else?
Well, yeah, we used to actually use, bolts in the rim that stop the tyre from coming off the tyre rim. In other words, it just got screwed in up the inside of the tyre so that the tyre could, if it did move. But lately, the tyre technology and their ability to make that section of the tyre consistent in diameter and stiff has been important. The rim itself, again, some teams have a knurled finish, you might call it, or horizontal lines going along that area, so the tyre comes out onto that, so those little horizontal lines bite into the tyre to stop it slipping. And again, they're sort of shot peened and they're cleaned after every application. So the fit, the bead diameter now is defined by the tyre company. So that's through years of understanding how tight they can make the tyre fit onto the rim. And it's also about how stiff that part of the rim is. You will see on most rims. Currently, it's not. The rims are one make rim, so they're defined by the tyre company and the FIA, and everybody uses the same rim. And there will be a stiffening bead around that area where the tyre bead sits on the inside of the rim to make sure that there's no deformation on the rim. So it's just years of fit size and proving that has allowed them to get to a point where the tyres very, very seldom now slip on the rim. And I say very seldom because that's, it still does happen now and again. You will, the very odd time hear of people getting a vibration, and that might be because the tyre has slipped fractionally. But the rims are balanced without the tyre. The tyres are balanced without the rim. So at the end of the day, the combination of the tyre and the rim take very little sort of balancing. So if it does move a little bit, it's not really the end of the world, whereas in the old days it used to be a nightmare because the tyre was so out of balance. You were applying lots and lots of weights onto the rim just to counteract it. And when it slipped, then it became a big problem. But nowadays, no, it's not a problem.
Well, a great set of questions there. So thanks very much to everybody who sent them in. And thanks very much, Gary, as always, for your answers. Obviously, if you've got a question for Gary, send it to podcast@therace.com. That's podcast@the-race.com. And we'll take them on in a future episode. We'll be back in a couple of weeks with more from Gary.
The Athletic.